I shouldn't be this excited about this, but I finally got the if-else control flow in Cruxforth working, and it was not easy. So this is my notebook that I went through to try and figure this stuff out. I went through 3 iterations just in code and probably 20 iterations writing things out, trying to figure it out. It starts here. And that's it, I think. Yeah. So I want to give you guys a little diagram and explanation of how this whole stack thing works. Here's just a potential if-then statement that we might put in forth. It'll start with an if and end with a then. And you can tell where we're at in the nest based on that if and then. If we have an if here, and then we see another if, then we know we need 2 thens before we get to, the outer level of this if statement. So in our program, we're going to have a control flow stack. And this is used, I think, differently probably than like assembly language Forth implementations would use it. And we have our integer stack. This is just something I kind of came up with off the top of my head after trying a few different things. So there may be a better way to do it. This is the best way I could come up with. And, if it is the best way, then that was a miracle. So I didn't really know how to research this on Google. There's not a whole lot of blog posts about how to implement a low-level language compiler in a high-level language. So anyway, we have our control flow stack. We have our integer stack. That's where we put all our numbers just like usual. So here, let's just go through this statement and I can kind of explain as we go through this. So we have a -1. That's going to get put on our integer stack. It's fed into our interpreter, put on the integer stack because it's an integer. Then we have our if. The if is going to, first of all, look and see if there's anything on the control flow stack. Since there's not, it's going to go to the integer stack. When it goes to the integer stack, it's going to see the -1. -1 equals true. 0 equals false. So it's going to see that and get true. It's going to take that off the integer stack and put true on the control flow stack. So now with the control flow stack, we get 2 pieces of information. We get what this if nest's condition is, and then we also know which nest we're in because there's only 1 true on this stack, which is an array, just like this integer stack. So we have those 2 pieces of information. With those, we can get through the rest of this and everything makes sense in the end. So if the if was true, so that means we want to read everything from this if until it's matching else. Now, which else matches it? Well, if there's another if, then the next else is going to match that if, not that if, right? You can tell if, else, then. You can kind of distinguish the if, else. So here's what we have. So we have if, else, then. Those 3 are matching, and then this one is nested in this if, else. We have true on our control flow stack, so we want to read everything starting here all the way to here at this point. At this point, we don't want to read anything after the else, right? Because if the value is true, then do this. If it's not true, then do this. So we only want to read everything till the else. Okay, so we get a 10, and that is readable. So that goes onto the integer stack. We have another if here. Now that's going to look at the control flow stack first, just like this did. If it sees that there's something on the control flow stack, it checks its value. If that value is true, then it's going to evaluate the integer stack. If the value is false, it's automatically just going to be false. If this outer if was false, that would mean all of this stuff that's underlined, we would not want to read it. So if there's any nested ifs in it, then they have to be false as well. They have to be. So, but this is true, so this could be true or false. So we're going to look at the integer stack. 10 is not -1, it's actually greater than -1. I should put anything, it's like anything less than 0 and anything greater than -1, and then, oops, I did that. Now those are backwards. So anything greater than -1 is false, anything less than 0 is true. So this one is greater than -1, so it's false. So now we have a false on the top of our control flow stack. So now we know that we're too deep in our nest, right? We're nested now. We can tell that because there's 2 values on our control flow stack. And we just processed that if. Now we have 20, but the top of the control flow stack is false, so we're not actually going to read anything until we get to that else. So since it's false, we don't read, so we just do nothing with that 20. Then we get to this else. Else's are kind of different than an if. Else's never would look at the integer stack. They always look back to an if. So if this else's parent if is false, which this one is, and if this if's parent is false, which it is not, so you only have to ever look at the parent if and then its parent. You never have to look back farther than that because of the way we're looking with ifs. If this if's parent is false, then it's automatically going to be false. So it all works out. It's really tricky to explain. You have to just really think through it. But so this if's parent is false, right? Because there's false on the control flow stack. So then it goes back one more to this value, which is true. It sees that that's true. So if the else's parent is false and the if's parent, this if's parent is true, then this else must be true. So instead of appending another value on the stack, we're only appending values with ifs. So instead, we just flip this value to true. Now, if this if was false and this if was false, then we would know that then this whole thing should be false, right? Because we would want to go until this outer if's else without reading anything, so we would leave it false. If this if was true, then this else would just automatically toggle to false, and it would just switch this to a false, the top value. And the reason it would do that is because that we were able to read everything from here to here, so we know that everything beyond that is readable. So then we don't want to read anything from the else to the then. So that's a little bit tricky. Hope I explained that okay. So we have our else that toggled our top value to true. And so since we're true, we look at our next value and it's true, so we can read it. So we put it on the stack since it's an integer. Then we have our then. Thens are very simple. They just take the top value off the stack. So it takes the top value off, and now we're back to our original nest, right? So this nest is gone now. It's off the stack. We just have one value on our stack, and it's that true. This else looks, is the if true or false? Now, if the else sees that it's on the very outer stack, it doesn't have to go to a parent, obviously. It can't. So it's just going to assume the parent was true, basically. And if the parent was true, if this if was false and its parent was true, then this would be true, right? The if was false, so we don't read anything from if to else, but we do read the else to the then. If this if is true, then this else has to be false. This if is true, we can tell that by this value on the stack, so else is false. So we flip that true to a false. And that means now we're not reading anything else on the stack. But then we get to this then, which takes that else, that top value, or that false, that top value off the stack. And now we're out of our nest, and we end up with 30 on the stack. So if we look at our original if-then statement, which is this. I just rewrote it because this is all crossed off. So we have our "-1, which means true. So our if is true. So if our if is true, then, then do this until the else. Then we put a 10 on the stack. And this if evaluates the stack, which is false. So we don't read anything until the else, and then else 30. So we get 30 on the stack. Okay. And then we're at this else, which would be false. If this is true, then do this and don't do this. And so we're not doing this. So we get 30 on the stack. Hope that explains it.